Okay, our last video in this Unit 7 where we have learned about our chemical reactions. We have figured out what the signs of the chemical reactions are. We have figured out how to balance chemical reactions, and we have really dove in deep to writing our own reactions for synthesis, decomposition, single replacement, double replacement, and now combustion. You will now be able to tackle a page like this where I give you a bunch of different starters for chemical reactions. I've given you the reactants, and you are supposed to know what to do with them. Show me what products would be created, and then balance at the end. Y'all are like, well, what is even going on here? Now, you will need some of your tools. You will absolutely need a periodic table, you guys. We need the periodic table. Specifically, also, if we have a double replacement reaction or a single replacement reaction, we know my single replacements will use the activity series, the who's hot and who's not list, right, to see if somebody will be replaced in a compound. And then my solubility rules, we're going to be using those for my double replacement reactions to see from the formation of this swapping of couples which one of those ionic compound products is a solid precipitate that is insoluble. Okay, since we've got probably a lot of ionic compounds going in on here, you may want to maybe have your colored periodic table accessible to you. Hopefully you are now at the point where we know what charge these ions are actually making when we create our ionic formulas. Have your list of polyatomic ions out, because sometimes polyatomic ions can be players in these ionic compounds. The last thing I want to mention is there is a difference between my honors page and my on-level page. My on-level page, I actually am giving you guys the formulas on the entire front side. But my honors kiddos, I'm starting you guys off hot. Your entire practice, mixed practice page, front and back, I give you the reactants, only the names. So you will have to construct formulas for all of your reactants in addition to your products. So that is the joy of being an honors student. But they are the same problems, okay? They are the same problems. It's just the on-level kids, I have given you the formulas. So I'm not going to work through hardly very many examples. You can refer to any of the previous videos on the specific types of reactions and how to predict the products for them depending on the type. What I am going to make sure we feel real warm and fuzzy about is identifying what type of reaction these reactions are going to be depending on what the reactants are. Remember, we look at this in terms of single people and couples, and doesn't mean we're going to be breaking up or splitting up or whatever, right? So yeah, 4 of my 5 types are just single people and couples. That can be anybody, right? That one last type, that combustion type, we know we are looking for specific things. So I actually like to pick out my combustion reactions first because I'm looking for specific elements and specific molecules. And then I can release that from my brain and tackle the other ones where I'm looking for couples or single people. So remember, a combustion reaction is going to be a hydrocarbon, something with C's and H's, and then the second reactant will be O2. So do I have any combustion reactions? I do. Straight out of the gate here, I got CH4 reacting with oxygen. I know that's combustion. And we get excited. Y'all, I don't even have to think about crisscross. I don't even have to think about using my periodic table. I can just knock that out, right? Any other combustions on this page? Let's see, looking for a hydrocarbon mixing with oxygen. Here we go. Totally a combustion. CO2 plus H2O. Amazing. And I think that may be the last one on the page. So I've done that first. I feel good about that. Now I'm going to switch my brain and start looking at these reactants and being like, are you a couple? Are you a single people? What does that mean for me? We may need to put some parentheses around some polyatomic ions because my couples are only between a red thing and a blue thing. So for this first example, I got a couple. Oh my gosh. Magnesium and hydroxide, my cation and my anion. And I actually have another couple here. It is hydrogen and nitrate. This is nitric acid, which my acids are ionic compound like. Y'all, it has appeared to me I have 2 couples. Well, what does that mean? If I have 2 couples, the option for them is to switch partners. You guys, this is a double replacement reaction where I will pair everybody up with their opposite partner, getting rid of the subscripts that I may see here on the reactant side, right? Get rid of that baggage from previous relationships, and I will figure out what the ratio is of these new ions to each other depending on what the charges of the ions are. cool. That is amazing. Look how fun that was for us. Next one down, next one down. I'm like, oh man, I got a single person chlorine, and you are a non-metal chlorine. Let's see. And I got a couple between sodium and bromine, right? Oh, a single person trying to break up a couple. That lets me know that the single person, whether he's a metal or a non-metal, he will be kicking out or trying to kick out the other one of his same type. Chlorine is a non-metal. He's going to try to kick out bromine. Let's just remind ourselves how we use the activity series to help us figure out if these things will occur. Chlorine is here. Bromine is there. Chlorine is higher up on the activity series, right, than bromine. So the prettier or more attractive or active person will be the one who gets the boyfriend in the couple. Okay, so poor bromine is not as attractive. He's lower on the list, so he actually does get kicked out. If you get into the case where the single person is not higher up than the person who is already in the couple, then you get to write in our no reaction is going to occur. But I was able to pick out this guy as a single replacement reaction because I saw the identifying features of a single and a couple. Yep. Okay, let's see what we got next. Oh, I got a single person, and I got a couple between hydrogen and sulfate. This is sulfuric acid. So this is another single replacement reaction, right? Except this time my single person is a metal who is going to try to kick out the other cation, the hydrogen metal acting guy. So I would look at aluminum and hydrogen, which in this case, yes, aluminum is higher up, so aluminum will kick out hydrogen. Okay, you notice I am not working through these problems. You may go back to the previous videos if you were like, I don't remember how to do a single replacement reaction. I got lots of examples. The purpose of this video is to remind ourselves how we figure out what type of reaction we are doing so you can then implement the rules that you learned from the previous videos. Okay, next one, lots of letters of the alphabet. No thank you, there are only two things in here. Yep, I've got sulfuric acid, and I've got sodium acetate. Two couples. We're going to switch partners with a double replacement reaction. This one's super fun. You're like, okay, I got a calcium, and I got an oxygen, and that is my only reactant. The only thing you can do if you have one reactant is a couple is they gonna break up. I will split apart calcium and oxygen. So this is a decomposition reaction. Keeping in mind that when I break people apart, they free. Do not bring any subscripts over if there were subscripts over here on the reactant side. But making sure that you're really watching out for your diatomics and make sure that they get two. Even when they're free. They always come in twos. Moving on down. I got zinc. Oh, hi, single person zinc, specifically a metal single person. And then, oh, it's a couple here between silver and nitrate. I love that, silver and nitrate, where I will be comparing zinc and silver, seeing who is more attractive on the activity series to see if the reaction will occur, okay? Next one, oh wait, I gotta write this as a single replacement reaction. And you do not need to do the colors. And at some point, you may not even need to do the parentheses. I would maybe keep the parentheses in there because balancing is a thing here. But this, we're just looking at couples, right? Yeah. So magnesium and oxygen, single magnesium, and then single oxygen. If I have two single guys, they're going to make a couple. This is a Taylor Swift and the Travis Kelce of it all, right? So making a couple is called a synthesis reaction. So hopefully, I think I'm gonna maybe stop there. Hopefully this is gonna kind of get you started, right? It is not that tricky. You guys, we can do so many fun, hard things. This is a really, really impressive, powerful chemistry skill that we've learned here. I'm so proud of us being only 10th graders. Like this, what a journey we have been on to get here. And so this ends our first semester of chemistry. We have created chemical equations. You're like, man, it took us a long time to even get to writing chemical equations. Yes, it did. But now that we've got our chemical equations, we're going to do so much with them next semester. I'm super excited.